3x power 4. I'll give you 1 minute, then I want the answer. I know you...
I found it on Google, but
Yeah, no, I'll do it. Let's see if these other guys can do it. Log 3x power 4. Yeah?
Tangent and moments, it's not on Google.
The link is broken?
Yeah. Audio.
Interesting. I'll have to fix that later.
I feel like it's a different link. Like, the link is written different.
No, it's
Come on, I've made 200 links on Moodle. Getting one of them wrong is not bad going. I'll have to fix that later today. Someone will need to email me to remind me to do that. Which, the class rep like to do that? Of course he would. This is what you live for. So if you can email me sometime today to fix that link. Okay, so log...
At night?
Anytime really, but you increase your chance of me doing something before I'm asleep.
Yeah, okay, 8:30.
I should still be awake by this time, yes. Log 3x4. So, does anybody know how to differentiate this? What to do here? Not yet. No.
Log 3 is 5.
Yeah, first log 3 plus log x4. Then log 3 plus 4 log x. Then we can differentiate. So we'll get 4 over x. And that's the answer. 1. We can't bring the 4 down because the 4 is not on the 3. It's only on the x. So we can bring it down here, but not here. Okay?
And after 5 always x.
It is not. Okay.
So we just, the last step when you derive it, how?
The derivative of log x is 1 over x. This is a rule. Yeah.
And you just multiply it by 4.
Yep.
And what about...
Yeah, what about the log 3?
Oh yeah, it goes down.
Why?
Because it's a number.
Yeah. Okay. Got that? Yes? Okay. Can you have a look at the practical problems in the calculus and tell me which ones you want to do? I'm sure there has to be at least one. If there's not at least one, then that means you're all geniuses or you didn't try them. I know which one I'd put money on. Do we have one to do?
5.
Do you even know what 5 is? It could be one I've just done in class and that would be embarrassing.
No, you didn't do 5.
Are you sure?
Yeah.
Right, maths part 1. Is it? Because 5 could be the coffee one I did in class. Because I remember the coffee one was around about the middle of the page. Could be not, yes. 4 was the coffee one. 5 I will do. Okay, let's have a look here. Express the number 8 as the sum of two numbers. Okay, so what we're looking at here is... Who's this now? Oh, this guy. Forgot about you.
Good luck finding a chair.
There's one over there in the corner. This way around. Full house. Right. Express 8 as the sum of two numbers, so we'll say x plus y, such that the result of multiplying their product by their difference is maximum. So multiplying their product, which is xy, by their difference, x minus y, is maximum. Now, I know that might seem a bit confusing, but I think it might help a little bit if I just show you with some number examples what exactly is going on here. Did anybody get this? What about over here? No?
I got one answer.
You got one of the x values. Then you also got the y value because you have to add to 8. But if you take 8 away from that answer, you get y. What do you mean no? What answer did you get for x?
3 something.
And why didn't you get a y?
I don't know, it wasn't, I think of.
But y is just 8 minus x.
Yeah, don't know.
It's a mystery.
I know that x is not 3, but I was getting 3.
You know x is not 3.
Yes, but I was
Why do you know it's not 3?
Because the answer is not.
Yeah, okay.
Like I know something's wrong with my working and I'm getting a 3. So I can't figure out where I'm going wrong.
So, this one here, they're looking for two numbers. We'll call them x and y. And they need to add to make 8. They have to make 8. And their product, the word product means x multiplied by y. And their difference, that means x minus y. And you want the product multiplied their difference to be a maximum. So you want this multiplied by this to be a maximum. And we kind of know what y is if we know x, because they have to add up to 8. So the y is going to be 8 minus whatever the x is. So for example, if I start with x is 0, let me just shrink this a little bit and shrink this a little bit. Okay, and these are the two things I can change. So if I start with 0 and 8, they add to make 8, that's good. Their product is 0, their difference is minus 8, and you multiply them together, you get 0. Is 0 maximum? Probably not. So let's try and go on to 1 then. No, thank you. We'll go down a little bit. 1, 2, 3, 4, 5, 6, 7, 8. Oh my goodness. Okay. And we'll increase the x's by 1. Okay, so you can see that, for example, when x is 1, y must be 7. They do add to 8. Their product is 7. Their difference is minus 6. And we've gotten smaller. So this is not really the direction we want. But if we look towards the end, for example, when x is 7, y is 1, their sum is 8, their product is 7, their difference is 6, and we have 42. So as we can kind of see, we've passed the maximum. We think 6 and 2, somewhere around here is probably best. Now what we can't see is that maybe it's not quite 6, maybe it's like 6.1 and 1.9. Maybe this will give us the maximum of their product by their difference. So let's calculate it, but I'm expecting 6 and 2 or 2 and 6 as an answer here, something like this. So I'll call this z, and this is what we want to make a maximum. So z is x times y times x minus y. I should change the y into 8 minus x by just using this here. And I'll change the y into 8 minus x, so that's 8 plus x then. So that would be x, 8 minus x, 2x minus 8. This will be cubic, and its derivative will be quadratic, which is kind of what we expect. So this will be 8x minus x squared times 2x minus 8. So if I multiply by 8x, I get 16x squared minus 8 times 8 is 64.
X cubed.
Thank you. 16. No, squared.
Yes, squared.
Glad we cleared that up. I just have my calculator ready for when I need to solve it. 16x squared minus 64x minus 2x cubed plus 8x squared. So that means z equals minus 2x cubed plus 24x squared minus 64x. We want to make this a maximum, so its derivative needs to be 0. Minus 6x squared plus 48x minus 64 equals 0. I suppose I could divide by minus 2. That would be 3x squared minus 24x plus 32 equals 0. That's as good as it's going to get. This doesn't have factors. I know it doesn't. So we'll have to use the formula here, x equals or x equals. And then once we have x, we can get the y, because we know that y is 8 minus x. So I'll have...
Wait,
Yes, did I make a mistake?
yeah, plus 64.
Plus 64?
65.
Minus 64. Minus plus. Yeah. Okay. Do you have two answers, please? Can you give me the two x's? You'll need the calculator. There's no factors here.
Why isn't these here?
I'm maximizing z, so it's z's derivative. Go on, you have the calculator right there. Give me the roots. Mode 50 something. 6.31.
1.79.
1.
869.
They don't add up to make it.
Hold on. But they don't need to add up to make 8.
1.69. Yeah.
3
They do add up to
minus 24, 32.
Most of them.
Hold on. 6.31, 1.69.
After they
So if x is 6.31, y must be 1.69. If x is 1.69, y must be 6.31. So the answer is z equals 6.31 plus 1.69, or z equals 1.69 plus 6.31. This pairing to make 8 makes this a maximum. It's an unusual example, I know, but it's a famous classic example, which is why I have it in the worksheet. Okay, write this down, please.
So the example of the question would be like practical problems?
Oh yeah, usually practical problems, yeah.
So like what is
Or
problem
part
Yeah.
B.
not from the
Part B, yeah. Yeah. What? You need to upgrade your phone. Nokia 2760 is what I recommend. It is nice, yeah.
Okay, we made a new phone now. And
Re-release an old phone.
no. They made a new phone, smartphone, it's really powerful.
Not interested. Okay. You have this? Yes? Okay. What example will I do next? You couldn't possibly be cold. You're cold.
Yeah.
What will I do next? Which one?
7.
What's 7 about? Yep, 7. Okay.
So for the maximum, we equate to 0, what was it?
Oh yeah, let's double check it's a maximum. Guys, let's double check this is a maximum. The second derivative, the difference is with the second derivative. For this to be a maximum, the second derivative needs to be a negative. The second derivative here is minus 12x plus 48. Yeah? Now this one's kind of interesting because Not both answers give me a maximum. One of them gives me a minimum.
Yeah, we have to choose the x and the y.
What do you mean?
We have to choose which value of x is. We have to choose if 1.69 is the x or is the y. That's what we have to do.
Yeah, but the x and the y, no, I get what you're saying, but the thing is this, if I use this, I get definitely a negative,
Yeah.
which makes this one
A minimum.
maximum. And if I use this for x, I get positive, which is a minimum. But that's kind of silly because these two are the same thing, like they're really the same answer. The reason for what is happening here is because I had to call one of them x and y to do this, but in the question I never said x and y. So what's happening is when you talk about their difference, you need to decide which is x and which is y. And this is the reason why it looks like you get a maximum and a minimum, because if you look at my spreadsheet, one of them will be a positive and one of them is a negative, but the difference is still 48. It just depends which way around. In other words, this example is a bit weird. It looks like there's a max and a min answer, but there's not really. It's just because of me calling one of them x and one of them y. In reality, this is the same answer, because these two are there's no difference between these. It's me calling this x and y that is making it look like there's two different answers. So it's quite weird. You can kind of avoid this if you say difference only means positive. Then what would happen is both answers would be a maximum. But it just gets a bit weird, that's all. Okay, let's have a look at 7. Isn't that what you said? 7, yeah. By using Pythagoras, find a formula for the square of the distance between the origin and the point xy. Okay. So, we have our xy graph. This is x, this is y, and here's the point xy. And we want the distance from the origin to this point using Pythagoras. Well, what's the distance from here to here? X, and here to here? Y. So this distance here, which we'll call it z, z equals root x squared plus y squared, but it's actually the square of the distance is what I want. Not actually the distance. I want the square of the distance. So I'll just call that an s for square. So the square of the distance is x squared plus y squared. So that answers part A. Part B, if y equals 1 over x, what's the formula now? So I tell you what the y is, it's 1 over x. What's the formula? Well, that's just s equals x squared plus 1 over x squared. So that means s equals x squared plus x minus 2. The curve looks something like this. Okay. C. What is the value of x and y that will make the squared distance be minimum? So we want to make this a minimum. So ds dx equals 2x minus 2x minus 3. And we need this to equal 0. So that means x minus 3 should equal 0. X should equal x minus 3. So that means x should equal 1 over x cubed. If I multiply both sides by x cubed, that means I get x4 should equal 1. Yeah?
So if you're multiplying by x cubed?
Yeah.
Okay.
Yes?
Yeah.
So we get two answers for the x here. What are they?
1 and minus 1.
Yeah, plus or minus 1, which means we have two answers for the y, plus or minus 1 as well, because remember y equals 1 over x, so it's just 1 over 1 and then 1 over minus 1. So we have two answers, 1, 1, minus 1, minus 1 are the two answers. But I need to figure out what the s is. So in both cases I think it's the same, because it'll just be 1 squared plus 1 squared, which is 1 plus 1, which is 2. So in both cases s is 2. And finally D, if the minimum distance, did I say minimum or maximum in the question? Yes, it is a minimum. If the minimum square distance is 2, what's the minimum distance then? It would be root 2. Now, you just have to be careful that what you're actually saying makes sense. So if I just go to the side for one moment. Let's imagine here I have a function x and y. So let's say x is minus 3, minus 2, 0, minus 3, minus 2, minus 1, 0, 1, 2, 3. And let's say the y is, I don't know,
3, 2, 1, 0, minus 1, minus 1,
I was thinking that, but I wanted more interesting.
75.
1, 2, 3.
0.
1, 0, minus 2, minus 100. Okay. No, that's too weird. Sorry. 0, 0.
3.
No, 1.
1 and a half.
1. 1 and a half. Okay.
Yay.
Now, for what value of x is y maximum here, for example?
Minus 1.
Yeah, when x is minus 1, the maximum value of y is 3. Now have a look at the y squareds. 1, 4, 9, 1, 0, 0, 3 over, 9 over 4, 2.125, is it?
Yeah.
No,
No.
2.25,
Yeah.
whatever. Where is y squared maximum?
3.
When x is
Minus 1.
minus 1. So the point I want to make is, when y is maximum or minimum, that's at the same place when y squared is maximum or minimum.
Yeah.
Now, that's not, I know it seems obvious, but such things aren't always true. It just works in the case of square. So, when y is maximum, its square will be maximum. When y is minimum, its square will be minimum, and vice versa. But it doesn't always work in all situations, and we'll see more in semester 2 maybe, when it doesn't work as nicely as this. But the point I'm making is, where this is a minimum is the same place where its square root is a minimum. So what happened was, we found that this point here, 1, 1, which makes a square distance of 2, it's right to say the minimum distance is also root 2. Now it might not be. You might have thought, well, maybe the square is at a minimum here, but maybe the distance is at a minimum somewhere else. But it's not possible. They must happen at the same place. In other words, it's right to take the square root here. Okay. This is actually a very useful trick, because it's much easier to like if you look back here, which is easier to differentiate, this or the distance, which is this? Well, it's much easier for this one. So this is why in the question I suggested looking at the square of the distance. It just makes finding this much easier to do in semester 1. In semester 2, you will learn how to differentiate this using something called the chain rule, for those who've done it before. Okay, so write this one down, please.
So, the x and the y values are the same?
No, one is 1, 1 and minus 1, minus 1, but it's not the x, y we cared about in the end, it's just a distance. And if you look at minus 1, you also get a 2 and a root 2 as well. Because what's happening here is when you square them, the sign doesn't matter, so it doesn't change the answer. Yep. You got that?
Yeah.
Yep. You wrote this down? Okay. What to have a look at next then? Oh, thanks. What's that? What do we want to have a look at next?
No,
I didn't.
Showing the odd numbers.
no, the 7 I didn't do the D.
Okay. Did you do 9?
No.
Then no, I won't do it. Wait, did you do it because... Did you not do it because it was too hard, or you were too lazy to do it?
No, I skipped it.
That's code for I was lazy to do it.
I did 10.
So, say meaning. Is there no 10? Let's have a look.
What's this?
Very busted.
I meant the question from the next lesson.
Indeed, yes. Okay, what else do we need to see here? Did people try these at home?
At least I went to 7.
Yes, at least you went to 7.
Many
The
others.
tangent and
Yeah, I don't think people did really try this at home. Yes?
the tangent and
You want to see something on that one?
the tangent lesson itself on Moodle, it doesn't work.
Oh my goodness! We said this at the start when you were not here.
Yeah, I know.
And
Yeah.
last week also.
And last week also when he was here.
Yeah, and you said open the video from last.
Yeah, and then as I was saying that, I realised the worksheet wasn't in the video, and I was going to correct myself, but said, nah, screw it. It can be a surprise for
It
them.
doesn't have the answers.
It is in the video. It doesn't have the answers.
Yeah.
But just don't make mistakes. I will upload it. Faisal is going to email me this evening to remind me to fix the link. But the link does work on one of the maths pages. So for example, maybe for the maths for business page it works. Because I did have it open in class. So you clicked it obviously on the maths for engineering page. Try the maths for business or the maths for science page. You don't have access to it.
No.
Ah. The maths for science people, could you open that link, the tangent? Tangent and normals link? It doesn't work for you either. It works.
This is not the one.
Tangents and normal. I'll fix the link anyways for the engineering page.
I'm good tomorrow.
What?
You want something that I don't have on me right now.
Money?
No. I never have that.
It works. If you can't wait till this evening,
Problem
one of the
solved.
science students can email it to you.
Yes. And I won't have to email you. Classmates.
You
have
can
to
wait.
solve that.
They thought maybe so. Right.
Could I transport this to get
The workbook? You're waiting until now to collect the workbook?
like this had last week and then
Yeah, I don't know what happened either.
This work.
Yeah, that's what happened. Did people try number 6? Guys, if you're not practicing at home, you're just causing trouble for yourself in the exam. No practice at home means you'll do badly in the exam. Do badly in the exam, you won't go to university. Do I care? Slightly, but I still get paid, even if you go or don't. So you need to be practicing these at home. Have you tried number 6? Number 6? Has anyone done number 6? Perfect. Do number 6 now, and then I'll put the answer up on the board. I'll help you out by drawing what you need to do in number 6. So in number 6, what you have is a square piece of paper. Square. I don't tell you the length, so you can call the length something like L. So here to here is L, and here to here is L. And what I need you to do, yeah, because it's a square. Square. No, no, don't do this. Don't do this. Square. 4 sides, all the same. Yes? What? No. Right, what I need you to do here is to cut out a square from each corner,
Oh, I don't know about that.
and I want you to cut out the right amount to make the volume of the box maximum. So what's going to happen is you're going to cut out a corner from each, and then you're going to fold it up to make a box. And the top of the box is open, of course, because there's no lid when you fold it up. So I want to make the volume maximum. I want to make the biggest box possible by cutting corners out from the square piece of paper. I want to know how much to cut out. So tell me what the X is, if we call this X.
Yeah, that's fine.
Well, 2x for each side. Okay, try this one. I think you get two answers here. Only one of the answers makes a maximum. The other answer will make a minimum. So you must choose the right answer. And once you've finished, I'll do it on the board. That has to be English. Okay, good. Yeah, I'm looking for the X. I'm looking for how much to cut off from the big square. two answers. One is good and the other is bad. So really only one answer. You have them, Lee?
What are your answers?
Sure. You have two answers? You need to think about which one to use, yeah. You have two answers? You have two answers? One answer? No answers? One answer. Faisal, you have two answers, yeah?
Yeah, I'm checking.
Oh yeah, but did you reject one of the answers, or do you think both are valid, or what?
No, one answer of X.
And what did you get for X?
I'm checking because.
No, tell me.
One is a half.
Yeah, and the other?
Is 1/6.
Correct. Well, which one are you going to take though?
I think it's the 1/6. I'm
What?
not sure yet. I didn't find the maximum and the minimum.
Okay, let's have a look. So, here, the volume. Well, how big is this side? L minus 2x, because you've cut x out. And this side is the same. And the height?
Is X.
X. So the volume is L minus 2x times L minus 2x times x, which will be L squared minus 4LX plus 4x squared times x, which will be L squared x minus 4LX squared plus 4x cubed. And we want to make this a maximum, so its derivative, which is L squared minus 8LX plus 12x squared, should equal 0. So you have 12x squared minus 8LX plus L squared equals 0. You must use the formula. Well, no, you could factorize it here. It'd be a bit tricky to factorize, but it's possible.
-6.
I know what I'm doing, So it has to be x and x. And at the back, it has to be L and L, because only L multiplies L to make L squared. Because this is a minus and this is a plus, it has to be minus and minus. We need two numbers that will make 12 in the front, but then 8 in the middle. So your choices are 4 and 3 or 6 and 2. We can see that, oh, it must be 6 and 2. Let's double check this. 6 by 2 is 12. L by L is L squared. That is minus 2LX minus 6LX minus 8LX. So we have x equals L over 6 or L over 2. Must be this answer. This one has to be rejected. What is the reason for rejecting this?
Me, tell you?
Go on, tell me.
Because you can't, if you take two x's from the same L, the L is gone,
Yeah.
which is impossible.
Well, no paper left. Yeah. So in this one here, in this answer, you cut half the length from each corner. So you go cut, 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 cut. You're left with no paper. Volume equals 0. Clearly the minimum. In this answer, you cut a sixth of the length from each corner. So if you want to imagine it, what you do is you break it up in, I'll draw it here for you, the paper.
It doesn't have to be 3D.
No, we won't do 3D. These are sixths, I assure you. What am I doing
Yeah, you added an extra one.
Did I? 1, 2, 3, 4, 5, 6. Yeah, okay.
One more button, that's it.
So, what I've done is broken this into 6 pieces. You have to cut off a 1/6 from each corner. So you cut this off, cut this off, cut this off, and cut this off, and then fold here, 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 and here, and fold it up. And the box you make has the maximum volume you can make. You can't make the box any bigger. This is its maximum then. I've seen this one in the exam before. They make it a tiny bit easier because in the question they give you the picture. They give you the picture that I drew. So that makes it a little bit easier, but not much easier. You still have to do all of this. And also, what I've not done is check maximum and minimum with the second derivative, which I'll finish by doing that. And what's the second derivative here? That would be 24x minus 8l. So if I put in, what is it, l over 6 into it, I'll get minus 4l, which is negative, which will be a maximum. And then if I put in l over 2, I'll get, let me see, 12x minus 8x, 4l, which is a positive, which makes it a minimum, as we taught from using common sense here. And the very last thing that they could ask you to do in the exam is actually calculate the volume. So if I just put L over 6 back into, let's say, this equation, L over 6 times 2 is L over 3, isn't it? L minus, oh please don't break my train of thought, please, I'm doing this in my head. This is L over 6 times 2 is L over 3. L minus L over 3 is 2L over 3. So this will be 4L squared over 9 times L over 6. That makes it 2. That makes it 3. So the volume is 2L cubed over 27. So this is the maximum volume you can make. So for example, if this was a 1 meter square, for example, then the maximum volume you can make is 2 over 27 meters cubed, as an example. You can't make the box any bigger than this. Okay, this is a great example of what you get in the exam in section B. They ask you to find a formula for the volume, to calculate its maximum by using the first and the second derivative, and then often the question finishes with what is the maximum volume, which would be the final part here. So this is an excellent example of what you get in the exam. This is a very, very typical exam question, just with the diagram. You need to be practicing these at home, okay? And we'll finish there.
Do you have a class now?
I have lunch now.
Can I ask you a small question in physics?
How small?
It's really small.
Okay, come up then. Footnotes in the coursework? Allowed.
Footnotes?
Yeah.
I know hundreds of them.